Assalamualaikum warahmatullahi wabarakatuh. Today I want to present problem-based learning project. This is from group 6. The topic is population growth and Newton law of cooling. Okay, I want to introduce my group members. First, Muhammad Nur Iskandar bin Mahdi. Second, Muhammad Afiq Fawaz bin Fahmizam. Third, me, Muhammad Faris Hamzi bin Muazim. Fourth, Nur Akilah binti Hisham. Last but not least, Siti Nur Aisyah binti Zula Zamar. So, the content from program-based learning project. First is introduction. Second, fila table. Third, minute meeting. Fourth, problem and solution. Lastly, discussion and conclusion. So, I want to present introduction population growth. First, let PT be the population at any time t. PO as the initial number of population and dp/dt is the rate of the population growth. We can see from the picture at the slide. So next, where k is a proportional constant. This is a first order separable ODE, where p can be found when solving the ODE. ODE is the order differential equation. So next, where C is the constant integration and A equal to E at T equal to O. The number of population is P equal to PO. A can be found equation of growth model is being used on the prediction of bacterial growth and human population. So next, I want to present about Newton law of cooling. It's a mathematical model that depicts how an object temperature change in the particular environment. The difference between the temperature of the object and the temperature of the environment surrounding the item proportional the rate of change in time of the temperature according to the law. So next, the formula where k is proportional constant. The VE sign indicates that the temperature lowering as a result of the cooling process. To determine T, separate and integrate the given equation. So next we can see at T equal to 0, cooling process are starting.
Hi, my name is Muhammad Nur Iskandar bin Mahdi, and I would like to share regarding our fila table based on problem 1 and problem 2. For the problem 1, the problem format is the rate of increase of the population of insects is proportional to the number P of insects present at any time T days after beginning of the experiment. Given that the population of insects at the beginning is S, and after 10 days is S to the power of 2. Find in terms of S. Number 1 is the population of insects after 5 days, and the second one is the days taken for the population of insects to be 3 times the original population. For the fact number 1 is rate of increase of the population of insects is proportional to P at any t days after beginning of the experiment. Then the fact number 2 is after 10 days, the population of insects is S to the power of 2. Next, the ideas. The reason number 1 is insects number growth because of breedings. Number 2, insects can multiply into hundreds or maybe thousands of them. Moving on to the learning issues. Number 1 is why is the population of insects is increasing? Number 2, what is the population of insects after particular days? Number 3, what is the proper method to solve this problem? And last one is how to appropriately calculate the population of the insects. Last but not least, the action plan or resource needed is number 1, utilize the appropriate formula, and number 2, using the website for any references. Next, problem number 2. The problem format is you remove a cake from an oven at 10:30 AM. At that time, its temperature is measured at 300 Fahrenheit. and was put on the table where the temperature of the dining room is 70 Fahrenheit. At 10:33, the temperature is 200 Fahrenheit. You want to eat the cake when the temperature is 85 Fahrenheit. Then how long will you have to wait for the cake to cool off to 85 Fahrenheit? Suddenly, you change your mind and want to eat the cake with your friend, but your friend will be home about an hour later. So what is the temperature of the cake when your friend reaches home? Fact number 1 that we got is you remove a cake from an oven at 10:30 a.m. and the temperature was 300 Fahrenheit. Number 2, you want to eat the cake with your friend an hour later. Next, the ideas that we got is reason number 1, the cake will follow the temperature of the dining room if exposed. Number 2, the heat from the cake transfers to the environment of the dining room. Moving on to our learning issues. Number 1, what is the cake temperature when your friend reaches home? How long you need to wait for the cake to cool off to 85 Fahrenheit? And number 3 is what is the best method to solve the problem? Last but not least, the action plan or resource needed. Number 1 is utilize the appropriate formula, and number 2 is using internet as reference.
So now I will talk about problem and solution. Our first problem is about population growth. The problem is the rate of increase of the population of insects is proportional to the number P of insects present at any time T days after the beginning of the experiment. Given that the population of insects at the beginning is S and after 10 days is S power of 2. Find in terms of S. The first one, the population of insects after 5 days, and the second one, the days taken for the population of insects to be 3 times the original. So now I will discuss the solution. Question number 1, we need to find the population of insects after 5 days. So first, we need to find the value of K and insert in the equation P equal to PO exponent power of KT. PO is population initial and our PO is equal to S. By using all the information given, insert in the equation and we will get S power of 2 equal to S exponent power of K10. After we simplify it, we will get exponent power of 10K equal to S. Take ln on both sides and we will get ln exponent power of 10K equal to ln S. By using log rules, we can bring 10K move forward and it will become 10K ln exponent equal to ln S. Then, please bear in your mind, ln exponent is equal to 1. So, we will get 10K equal to ln S and K equal to ln S over 10. So the population of insects after 5 days is equal to S exponent power of 5 ln S over 10. Question number 2. We need to find the days taken for the population insects to be 3 times the original. So we need to find the T. By using the value of K that we got just now, insert in the equation P equal to PO exponent power of KT and our PO is still the same, which is S. And it will become 3S equal to S exponent power of T ln S over 10. Then take ln on both sides and it will become ln 3 equal to ln exponent power of T ln S over 10. Then ln E will become 1. Then our equation will become ln 3 equal to ln T ln S over 10. And T will become 10 ln 3 over ln S. Our second problem is about Newton's law of cooling. The problem is you remove a cake from an oven at 10:30 a.m. At that time, its temperature is measured at 300 Fahrenheit and was put on the table where the temperature of the dining room is 70 Fahrenheit. At 10:33, its temperature is 200 Fahrenheit. You want to eat the cake when the temperature is 85 Fahrenheit. Then how long will you have to wait for the cake with your friend? But your friend will be home about 1 hour later. So what is the temperature of the cake when your friend reaches home? So now I will discuss the solution. I want to eat the cake at 85 Fahrenheit, but I need to figure out how long I should wait to eat that cake. So first, we need to find the value of k using equation t equal to te open bracket to minus te close bracket exponent power of negative kt. So by using all the information given, we insert in the equation and simplify it, we will get exponent power of negative k 0.05 equal to 0.57. Then take ln on both sides and ln exponent equal to 1. So we will get k equal to 11.2424. We want to find T when temperature equal to 85 Fahrenheit. So using the value of K that we got just now, we put back in the equation, and after simplify it, we will get exponent power of negative 11.2424 T equal to 15 over 230. So then we put ln on both sides and ln exponent equal to 1. Then we will get T equal to 0.2428. 0.2428 need to time with 60 and we will get 15 minutes. Therefore, I must wait for 15 minutes to eat the cake. Suddenly, I changed my mind because I want to eat with my friend, but she will be home about 1 hour later. So I need to find the temperature after an hour using the formula and value of K that already stated. 1 hour equal to 60 minutes. The formula is T equal to Te open bracket To minus Te close bracket exponent power of negative KT. So we put all the information into that formula and we will get the temperature after 1 hour is 70 Fahrenheit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nurasha Mdizulazama and today I will be present about discussion and conclusion for Newton's law of cooling question 4. According to Newton's law of cooling, the temperature of a body varies at a rate proportional to the temperature differential between the body and its surrounding. In this case, the initial temperature of the cake was 300 degrees Fahrenheit and at dining room the temperature was 70 degrees Fahrenheit. However, the temperature dropped to 200 degrees Fahrenheit at 10:33 AM. In the meantime, the temperature was rapidly rising, so we listed temperature that given in the statement, which is TO equals to 300 degrees Fahrenheit and TE equals to 70 degrees Fahrenheit. Then using the equation TT equals to TE in the bracket TO minus TE, E negative KT to find K, referring to the above statement, we can solve the question by finding the K value. Using the value of K that we got to find the value of T when T equals to 85 degrees Fahrenheit. Based on the information gathered, integration will take place. After we got the value of T, we divided it to 60 minutes because 1 hour is equivalent to 60 minutes. So that answer will be to wait for 15 minutes to eat the cake. To find the temperature after an hour using the formula and value of K that are already stated, 1 hour equals to 60 minutes. We already knew when he was scheduled to have the cake, but he opted to wait another hour for his friend. As a result, we use the same value of K that we found before calculate the temperature of the cake for the next 1 hour with the formula T we obtained to calculate the time he is expected to consume the cake. As a result, we use the same value of K that we found before calculate the temperature of the cake for the next 1 hour with the formula T we obtained to calculate the time he is expected to consume the cake. As a result, a cake with temperature of 70 degrees Fahrenheit is achieved. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Afiq Fauz bin Famizam. So I will talk about this question, problem 1. Based on the first equation, we examine the requirement of the question as well as the points given in the question to solve the given problem. Given in the question, the rate of the population of insects is proportional to the number P, which indicates the insect present at any of time, T. After beginning of the experiment, P is a constant and always increase as T increase. We use this equation stated in the slide. The initial population and PT is the 10th day. The equation POEKT actually is to find PT, but PT has been given. So we make some comparison to determine the answer. For question B, based on the same equation stated in the slide, basically this equation is to find a value of T. We actually know ST is equal to 3S. So we just need to enter in the formula and make some calculation to get the answer.